This is the start of Unit 4, and we're going to talk about polynomial functions. We've already talked about several functions. Just kind of want to remind you and go back and talk about what makes a function a function. So let's start with the first function that you talked about. This wasn't in Algebra 2, this was in Algebra 1. This type of function is called a constant function. Notice there's no variable on this one, it's just a constant term. And when you graph something like this would be the same thing as y equals 5. And so the graph would look like just a horizontal line going through y equals 5. So that was a constant function. Also in Algebra 1, you talked about a function like this. F of x equals x. It's the same thing as y equals x. The output value is based off of whatever you put as the input. This one's called a linear function. When you graph it, it looks something like this. The next one we talked about was in Algebra 2. We just got done with the Unit 3. It was called a quadratic. And the quadratic function, we know it's a function. It looks like this, y equals x squared. The output value is dependent on the input value. And when you graph a quadratic, you have something that looks like this. Could also be something that's an upside down parabola. Same thing with linear. It could be like this. Now, with constant, it's not the one that goes up and down because that's an x equals, so it's not a vertical. But here, this would be y equals positive x. This would be y equals negative x. So we have a positive x squared and a negative x squared. We'll get to these. F of x equals x cubed, and we'll call that one a cubic function. And you're going to see whenever we get more into the cubic unit that a cubic function looks something like this. And if it's negative, it looks something like this. We also can talk about a quartic function. So each one of these names, you're noticing that the exponent really helps you describe it. So this one will be quartic. And it looks really weird. It's like, it can go something like this, or it has kind of something like that, or maybe upside down, something like this. So you kind of get the idea. These are all functions because if I tried to do the vertical line test, they would just hit each one of these in one spot. So for every input, you have exactly one output. That's what makes a function a function. So because it's a function, instead of writing y equals x to the fourth, we can write f of x equals x to the fourth. That makes this function notation. So in this unit, we're going to talk more about what happens when this number is pretty much anything. So we talked about linears all in themselves, quadratic all in themselves, and we'll get to cubic. But this is going to be whenever you have pretty much any kind of exponent. There'll be certain rules for those particular things. So just as a reminder, when you write a function in standard form, regardless of what this first term is, maybe some kind of number, if the first term is an x to the 7th power, then what comes after it should be x to the 6th. The exponents should be getting smaller as they go. Now you could totally skip something, like maybe we don't have an x to the 5th, so it could go x to the 4th, and then maybe x to the 1st, then maybe the constant term, okay? So this has to be written in order from the biggest exponent to the smallest. This number is called the leading coefficient. So the leading coefficient is the number that comes in front of the variable with the highest exponent. This highest exponent tells us the degree of the polynomial. And those are going to tell us certain things about our graph. We already know for a quadratic, this number is going to tell us whether it opens up or down. So same thing is going to happen here. It's going to tell us whether it opens up or down, if it's wide or narrow, or what its end behavior is going to be. And I'll talk about that in just a minute. So let's go ahead and write here the new thing that we know. This number is going to tell us about our end behavior. And I'll explain what that means in just a moment. Just like a quadratic and just like a linear, this last number is going to tell us our y-intercept. And the reason that does that is because if I put 0 in for x, the number I get for y is the y-intercept. So if I put 0 in for all of these x's, all I'm left with is this number. So that's why it becomes the y-intercept.